Hello, this is a video assignment for Koios blockchain course minor. My name is Maxim and I will start by describing the flaws and drawbacks of current monetary system. I chose this topic because, being a finance student, such things as monetary and banking systems are very important to me, and I see that blockchain as an opportunity to solve the problems which are currently making the system ineffective. Um, the main disadvantages of the current banking systems is that all other banks are centralized ledgers, and though they offer better efficiency on the local level, each and every one of them is powerless from facing three problems of decentralized ledger. These are loss of data, where banks can lose your transaction while in process. For example, the bank has total control which transactions are posted on the ledger because it's a centralized asset ledger, which lists all transactions that it is controlled by single entity, such as a bank statement. By this, they can find you and directly take money away from your account. This is a danger of centralized ledger because if the entity in charge has malicious intent, it can do some serious damage to the clients. And we see it here and there, where we see dishonesty and abuse of power made by bank workers. We see exclusion because we cannot see uh, the the inner the inner system of the bank ledger, and we don't know if it is correct. And one of the most common ones is a loss of data when banks just uh, can either lose your data or your transactions. Another disadvantage of a centralized ledger is that the controlling entity can shut down without notice and transactions will no longer will be processed. Giving this kind of authority to someone will result in error, whether it be accidental or not. And the next one is the scalability trilemma. Uh, I chose this topic because it is now being one of the things that is being worked on, and very soon it will be resolved. But let me explain it. Since Bitcoin's birth in 2009, blockchain technology has demonstrated its uh, its potential. However, it is still quite young and must overcome numerous obstacles before it can be widely adopted. This prompted Vitalik Buterin, the creator of Ethereum, to use the phrase blockchain trilemma or scalability trilemma to better comprehend how these issues are interconnected by grouping them under one umbrella word. With the introduction of Bitcoin, distributed data storage acquired a new use case and evolved into public decentralized ledgers, and the CAP theorem evolved into what is now known as the scalability trilemma. The trilemma in the context of current blockchains contends that while the ideal blockchain should be decentralized, safe, and scalable, there can only be two of three. This is most likely the most significant obstacle that blockchains must solve before the technology can be widely used. The uh, the elements of the scalability trilemma are decentralization, which refers to the number of nodes that run the blockchain. Security is related to code and, more crucially, consensus processes like proof of work in Bitcoin and proof of stake in Ethereum. And scalability is the blockchain's capacity to maintain an acceptable transaction speed. The blockchain trilemma was developed as a means to visualize and better comprehend the problems associated with the development and adoption of blockchain technology, uh, as well as how they interact with one another. Uh, but let me explain more about what is scalability, because this is quite important in the today's development of blockchain. So the blockchain scalability refers to its capacity to sustain high transactional throughput and future expansion. This means that the use cases increase and blockchain technology adoption rises. The performance of a scalable blockchain will not suffer. Blockchains that function badly as adoption grows are considered to be unable to scale and are considered as less popular and less effective blockchains. According to the blockchain trilemma, more scalability is feasible, but security, decentralization, or both would suffer as a result. Scalability is the only option for blockchain network to compete with older centralized systems that have significantly greater network settlement speeds and usability at this moment. While many blockchain systems have achieved decentralization and security, scalability remains a big problem for most of them. Uh, Today we have developed tools to comprehend with this problem actually. Now the increasing popularity of layer 1 solutions such as sharding and improving the consensus mechanism work along with layer 2 solutions such as nesting and rollups to mitigate this problem. Now we are moving on to the final one, which is the cryptography. I chose this topic because it's one of the most essential things that can be in blockchain because everything there works on it. Uh, so each transaction is recorded on blockchain using encrypted data. Most vital parts of hashing public and most vital parts of cryptography used in blockchains are hashing, public and private keys, and also digital signatures. Uh, Hashing in blockchain refers to the process of having an input item or of whatever length reflecting an output item of a fixed length. If we take the example of blockchain using cryptocurrencies, transactions of varying lengths are run through a given hashing algorithm and all give an output that is of a fixed length. This is regardless of the length of the input transaction. The output is what we call a hash. A good example is SHA-256, which is currently used in Bitcoin and many other blockchains. Uh, SHA-256 always gives an output result of a fixed length, which has 256 bits, and the output is 32 bytes. This is always the case whether the transaction is just a single word or a complex transaction with huge amounts of data. What this means is that keeping track of transaction becomes easier when you can recall trace the hash. The size of the hash will depend on the hash function utilized, but the output using the particular hashing algorithm will be of a specific size. It is impossible to reverse the hash because it is a one-way door, and which makes all the transactions hashed, safe, and free from interaction from third parties. Now we're moving on to the public and private keys. Uh, Public key allows you to receive cryptocurrency transactions. It's a cryptographic code that is paired to a private key. While anyone can send transactions to the public key, you need a private key to unlock them and prove that you're owner of the cryptocurrency received in the transaction. The public key that can receive transactions is usually an address, which is simply a shortened form of your public key. Therefore, you can freely share your public key without worry. You may have seen donation pages for content creators, for example, or charities, with a public key for the crypto addresses online. Examples include Red Cross or any uh, art galleries and charities. Uh, while so they just use the public keys for the crypto addresses online, and no one is able to steal money for them because this way they can only receive the money. While anyone can donate, you'd need a private key to unlock and access the donated funds. A private key gives you an ability to prove ownership or spend the funds associated with a public address. A private key can take many forms. It can be an SHA-256 bit hash. It can be a 64-digit hexadecimal code. It can be a QR, or it can even be a mnemonic phrase, like it is with a MetaMask, as a good example, and many other Bitcoin wallets. Regardless of its form, a private key is an astronomically large number, and it's large for a good reason. While you can generate a public key with a private key, doing the opposite is practically impossible because it's one-way trapdoor function as well as a hash on which it is based. You can have any number of public keys connected to a private key. Uh, Now we are moving on to a more specific one of signing and transacting the cryptocurrencies. They are called digital signatures. For a transaction on the blockchain to be complete, it needs to be signed. The steps for someone to send you a transaction are: a transaction is encrypted using a public key. The transaction can only be decrypted by the accompanying private key. Uh, Next, the transaction is signed using the private key, which proves that the transaction hasn't been modified. The digital signature is generated through combining the private key with the data being sent in the transaction. Finally, the transaction can be verified as authentic using the accompanying public key. You digitally sign a transaction to prove you're the owner of the funds. Nodes check and authenticate transactions automatically. Any unauthenticated transactions get rejected by the network. And an authentic mined transaction on the blockchain is irreversible, which means if you send the money on the wrong account, it's gone, and no signature or hash will help with this. So I think on this we are finished. Uh, Hope you liked it. Well, that's at least sufficient grade.